In this video, we will introduce the concept of a limit. We say that the limit as x approaches a of the function f of x is equal to the number L if the values of the function f of x are close to L whenever x is close to that input value a, but not equal to a. So from an intuitive perspective, we're saying that when x is close to the point a, the function f of x is close to that value L. So let's investigate this concept with a motivating example. Let's see if we can determine what is the limit as x approaches 1 of the function x squared minus 1 over x minus 1. And notice at this point x equals 1 was picked for a particular reason. The function that we have here is undefined at x equals 1. What we are interested in is not what happens at the point 1, but what happens when those inputs or those x values are really close to 1. Now, two perfectly good ways to explore this would be to do so numerically, that is by creating a table using our calculator, or graphically by graphing the function and investigating what happens. So let's begin with the numerical investigation. So I've created a table where I've used inputs x, and I've gotten the outputs by plugging into this desired function. And the question is, as those inputs become close to 1, what are the outputs going to become close to? And if we think about approaching 1 or being close to 1, there's two possibilities. You can be a little bit bigger than 1 or a little bit less than 1. So we have to think about kind of coming to 1 from the left and coming to 1 from the right. In this right hand of the column, you can see the corresponding values. So as we get closer and closer to 1 as our input, those outputs seem to be getting really close to 2. So for this reason, we would say that the limit as x approaches 1 of the function f of x, which is x squared minus 1 over x minus 1, is equal to the number 2. Let's also think about this from a more graphical perspective. So if I wanted to sketch a graph of this function, we know that the function is undefined at 1. So at 1 it's undefined. But when x is not equal to 1, well, our function is x squared minus 1 over x minus 1. And x squared minus 1 factors as x minus 1, x plus 1. So the x minus 1's cancel, and we're simply left with the line x plus 1. So when x is not equal to 1, what we will have is our function is defined as x plus 1. So x plus 1 would be a line of slope 1 with y-intercept 2. So if we sketch this and leave an open dot where x is at x equals 1, this would correspond to the graph of the function f of x equals x squared minus 1 over x minus 1. Now, keeping in mind that we are unconcerned about what happens at 1, so not equal to 1, but arbitrarily close to it. So if I think about plugging in inputs just to the left of 1, graphically what I see happening is my values are getting closer and closer to this open circle, which corresponds to a value of 2. Likewise, if I think about approaching 1 from the right-hand side, the outputs on our function are becoming closer and closer to that open circle from the right and above, i.e. that value 2. So from a graphical perspective, what we're noting is as we plug in inputs close to 1, those outputs are becoming really close to 2. So from the graphical investigation, we also have that the limit as x approaches 1 of this desired function is equal to 2.